Good afternoon, my YouTube viewers. In this particular video, what we're going to do is we're going to perform a hypothesis test on additives, on car additives. And so basically, a car manufacturer wonders if an additive will increase fuel efficiency by at least 3 miles per gallon. So your null hypothesis is the sample mean is greater than or equal to 3, and the alternate hypothesis is the sample mean is less than 3. And what we're going to do is we're going to perform a one-tailed t-test to answer this question. And we're going to write a program in Python to answer this question. So in order to execute the program, what we need to do is we need to import 3 libraries. So we're going to import NumPy as NP, which is a numeric library that performs numeric computations. It creates NumPy arrays, and it also creates distributions. And then we're going to import scipy.stats as stats. Scipy is Python's scientific library, and stats is the statistical module within scipy. And then we're going to import matplotlib.pyplot as PLT, and this is the visualization library. So what we're going to do is we're going to define our parameters. So the population mean equals 3, and the number of samples is 150. The sample mean is 2.9. So that means there's a difference of 0.1 between the population mean and the sample mean. Standard deviation is 1.35, and the alpha, which is the significance level, is 0.05. So we're going to calculate our t-score. So your t-score is the sample mean minus the population mean. So that is negative 0.1 divided by the standard deviation, which is 1.35, divided by the square root of the number of samples. And the number of samples is 150. So what we're going to do is we're going to come over here. So our standard deviation is 1.35, I believe. 1.35. And then divided by the square root of the number of samples. So divided by 150 square root equals, so it's 0.11027. And then it's going to be sample mean 2.9 minus 3 is 0.1. 0.1 divided by that. So we'll say 0.1 divided by 0.110227. So we've got a t-score. We think that is a t-score of negative 0.907. So that's what we think is a t-score. And obviously, Python is a much better mathematician than I am. So hope I didn't get it wrong. Now we're going to calculate the p-value for a one-tailed test. So p-value equals stats.t.cdf. So t means it's a t distribution, CDF means it's a cumulative distribution function, brackets, t-square, comma, degree of freedoms equals the number of samples minus 1. So that means your degree of freedom is going to be 149. So you're going to output the results of your t-score and your p-value. So basically, if the p-value is less than alpha or less than 0.05, you're going to reject the null hypothesis. The sample mean is significantly lower than the population mean. If the p-value is greater than alpha of 0.05, you're going to print fail to reject the null hypothesis. The sample mean is not significantly lower than the population mean. So we're going to plot the t-distribution. So x equals np.line space, brackets, -4, 4, 1000. Y equals stats.t.pdf, and PDF is probability distribution function, brackets, x, df equals number of samples minus 1. So that's 149. So we're going to plot the t-distribution, plt.plot, x, y, label equals t-distribution, color equals blue. So now we're going to shade the critical region. Critical value equals stats.t.ppf. ppf stands for percentage point function, brackets, alpha is 0.05, df equals number of samples minus 1, so that's 149. ple dot fill between, brackets, x, 0, y, where, brackets, x is less than or equal to critical value, color equals red, alpha equals 0.5, label equals critical region. So now what we do is we mark the t-score on the plot, plt.ax line, brackets, t-score, color equals green, line style equals dashed, line width equals 2, label equals t-score. So we're going to add titles and labels. So the title is one-tailed t-test. The x label is t-square. The y label is probability density. And then you get a legend, and then we're going to show it. So t-score is negative 0.9072. And that's what I got. So I calculated it correctly, which is good. The p-value is 0.1829. So since the p-value is higher than the alpha of 0.05, you're going to fail to reject the null hypothesis. The sample mean is not significantly lower than the population mean. And then so you can see a graphic of what we have done. So you can see that the blue line is your t-distribution, and the red is your one-tailed critical region. And you can see that your t-score is before the critical region. And since the t-score is before the critical region, that means that you fail to reject the null hypothesis. So that concludes this video. The next video is going to be on another hypothesis test, and I hope that you decide to watch it.